Today we're going to be starting in on 5.3, graphing quadratic inequalities in two variables. I just want to pause for a second and remind ourselves what kind of inequalities we've been working with so far. We've been working with quadratic inequalities in one variable, so that means that we only have our x variable, not our x and y's. And our solutions, so they look something like this. Okay, our quadratic inequalities in one variable. They can be in different forms, like we can have, say, like x squared minus 6 is greater than x or 2x or something like that. But they can all be simplified, set one side equal to 0, and then have the quadratic equation on one side. These sorts of things just deal with our x variable. So we're talking about solutions that can be plotted on number lines. So we have two different types of solutions. We have less than or equal to, where we have filled in dots, or we can have open dots, which is just the greater than or less than. If you want to have a reminder of how to plot these solutions on the number line, you can look back to 5.1. The next thing that we learned about was linear inequalities in two variables. So remember, guys, this means that we have a shaded region. Whereas these guys, just since it's one variable, we only have a line. Since we have two variables, kind of like two dimensions, we have a shaded region. The lines can be found in this form right here. Ax plus by plus c is greater than 0, or less than 0, or greater than or equal to, or just less than or equal to. The last thing that we want to talk about when it comes to shaded regions is precisely what the title says. Quadratic inequalities in two variables. So quadratic inequalities in two variables look very much like in the same as the one variable, only we have two variables instead. So quadratic inequality in two variables. And if you, this right here, that's just my short form for variables, looks something like this. Y is greater than ax squared plus bx plus c, or y is greater than or equal to ax squared plus bx plus c. I think you see where this is going. Y is less than ax squared plus bx plus c. And y is less than or equal to ax squared plus bx plus c. Alright, so we're finding out where y is less than this quadratic equation. This looks like it looks like a function. The only thing that's different is that we're going to have a shaded region again instead of just a line.